In this video, I want to show you why schools who want to bring change should be designed like an ecosystem, using systems thinking. Last year, I got to visit the Flower Dome and the Cloud Forest with my family, two iconic structures here in Singapore that are magical marvels of design with their breathtaking features. The Flower Dome holds the Guinness World Record for the largest columnless glass greenhouse. This cavernous conservatory has 3,332 glass panels that encloses this environment where temperature ranges from 23 Celsius to 25 Celsius. Creating the perfect habitat for an impressive array of plants from various corners of the globe. The Cloud Forest greeted us with a magnificent 35-meter indoor waterfall in the entrance. The forest showcases 9 distinct zones that replicate the environment of a mountaintop forest, found in Southeast Asia, Middle and South America, and provides a cool, moist atmosphere akin to tropical highland regions, found at elevations between 1,000 and 3,000 meters above sea level. Now, what blows me away about these structures is that horticulturalist designers, plant and soil specialists coordinate efforts to address the issues and improve the aesthetic or productive nature of the landscape, use their expertise of the natural world to skillfully and thoughtfully bring together over 250,000 diverse plant species, enabling them to thrive harmoniously in this captivating oasis. I immediately thought to myself, educators and school leaders in education, we should adopt a similar designer's mindset by utilizing our knowledge and understanding of the educational landscape to skillfully bring together diverse educational practices, resources, and approaches, fostering a harmonious learning environment where students can thrive academically, socially, and emotionally. One approach teachers and school leaders in education can use is systems thinking. Before we talk about what is systems thinking, let's first define the term system. According to her book, Thinking in Systems, Donella Meadows defines a system as an interconnected set of elements that is coherently organized in a way that achieves something. A system must consist of 3 kinds of things: elements, interconnections, and a function or purpose. So what is systems thinking? In their journal article, A Definition of Systems Thinking, a Systems Approach, Ross Arnold and John Wade define system thinking as a set of synergistic analytic skills used to improve the capability of identifying and understanding systems, predicting their behaviors, and devising modifications to them in order to produce desired effects. These skills work together as a system. Let's take a look at how the horticulturalists use the systems thinking approach to create a thriving ecosystem within Flower Dome and the Cloud Forest. Let's start with the desired effect. The desired effect was to create an artificially designed, thriving, living ecosystem that is viable. To do this, the horticulturalists needed a deep understanding of the elements, interconnections, and functions and purpose within the system of the structures. In an interview with naturesacred.org, Dr. Adrian H. Liu explained how his team of horticulturalists identified specific elements that helped achieve the desired effect, like breeding capabilities, and propagate various horticultural ornamentals, research into soil science and plant physiology, studying factors such as light levels, temperature, and their impact on flowering. Additionally, the department handles plant interpretation, creating engaging and accurate descriptions of plants, including their species and ethnobotanical uses. In addition, the team has established elements that are supporting systems and spaces to make sure that these domes and forests are viable, like a research facility with a lab, tissue culture facilities, and research conservatories. The team used this understanding of elements, interconnections, and functions of the system to resolve horticultural problems within these artificial environments. So how does this work in education? So last school year, I incorporated the systems thinking approach within the technology, computer science, and robotics engineering curriculum review, or the TCR review. As a team, we designed multiple strategies that we believe will increase our likelihood of changing from our current reality to the ideal state: high-quality STEM project-based learning experiences. This upcoming school year, we are implementing these TCR strategies. So in preparation for this, I led the TCR review team to create a network map of our TCR system of implementing high-quality STEM learning, to think in systems and better understand the system, to not only implement strategies effectively, but also with impact and outcomes in viability, sustainability, and continuous improvement. We first took a look at the literature and examined some examples of STEM education systems or frameworks, looking at what elements and sub-elements each framework contained, and how they were interconnected in achieving their system's goals. Using the Jigsaw protocol, groups were created where each member read a resource and then shared out their learnings to the rest of the group, with one person documenting their findings. Using what they learned, the group then spent some time drafting their own network maps to help visualize and understand the elements and the interconnections between these elements within our high-quality STEM implementation system. It was a great way to discuss the relationship between these elements and how they interact with one another. Once each group created a draft framework, I took their prototypes and synthesized them the best I could, and ended up with this framework. The major elements are instructional design, core competencies, learning spaces, and supporting systems. Within these elements, there are sub-elements that specify what encompasses each of these big ideas. At the start of the school year, we hope to finalize this framework so that we can use it to guide us in our decision-making to move forward in our high-quality STEM work. It will help us to zoom in and zoom out to see different perspectives and get a more holistic view of our implementation work, visualizing things in a non-linear network, and even help us to redesign our framework as we experiment and prototype and test solutions within these elements and sub-elements. And through systems thinking, we now have a wider view and can better identify patterns, make connections, make better long-term choices, and identify leverage points that are not always obvious within the system or outside of it, that can be altered to change behaviors and create a big impact. The Flower Dome and the Cloud Forest in Singapore serve as a metaphor for systems thinking by highlighting the interconnectedness and interdependence of various elements within the system. Just as the diverse plant species thrive harmoniously under controlled conditions, systems thinking emphasizes the need to understand and consider the relationships and interactions between different components to achieve optimal outcomes in any complex system. Educators and school leaders should employ systems thinking to design the school experience by recognizing the interconnectedness of various elements, such as curriculum, teaching methods, student support, and staff development, and understanding how changes in one area can have ripple effects and impact the entire system. By taking a holistic approach and considering the dynamic relationships within the system, they can create an environment that promotes student and teacher success.